做那么 fancy。我觉得他们最后今天基本上说一下他们的问题。我最后想着，如果大家就有时间，我感觉可以问他每个几个问题，然后把那个 high level diagram 画一下。我觉得这个比较重要。好多人好像还是比较闷。那个不太相关嘛，跟人对。
但很多人都这么觉得。
啊，对，那个可以单独说。对，这个先把这个概念讲清楚。
Probably not a proper question for the people here, right? Needed to ask the people online, but online people want to be able to answer it here.
But I received no complaints about the online recording, so that's hopefully
Then shall we start?
Yeah, I think we're on the dot. Let's get started. So a very quick intro of Pascal. Pascal is doing a PhD with me and Brisbane and Mark Reynolds on temporal knowledge graph construction. Before his PhD, he has already done many years of industry software development as a full stack developer. So as you can see that he has a lot to offer. He got both the research side as well as the real industry experience. Even during his PhD, he had developed several award-winning systems that got first or best demo paper at EMNLP. So if you know about what that conference is, it's empirical methods for natural language processing. So every year it attracts about 10,000 submissions. So this is like the top-notch conference in the world. And he just recently came back from another top-notch conference, ACL. So make use of his knowledge and ask a lot of questions. And he just suggested after the lecture we can talk about your pain points in your projects. And then we'll try to develop your system diagram together. So we'll use that as an interactive activity for today. And Pascal's topic is going to be on AI engineering. So give you an overview of what AI engineering is, and then you can find bits of components that's related to your project. And also I have to thank him so much for making himself available for today, and he had to juggle a very big family commitment to come here and give us the guest lecture. Thanks, Pascal.
Okay, thank you everyone. I think I'm not that good enough, but I will try to be that good enough. So I think today our section is about introduction to AI engineering with large language models. And I say it's leaps from the algorithm to the reality. The structure today, I think it will be quite simple. We're just trying to get the simple concepts to be clear in our mind. So I think our approach is get yourself have a big map in your mind about what will be the concepts you will need. And then when you encounter problems, when you're doing the project, you kind of being able to navigate to the specific area and formalize specific questions. Then you can use the AI, probably answer your question, or you can come to us, answer your question. So as we already said, it's an AI area, so it's kind of what's the most important capability in this area actually is capability to formalize a proper question, because answers probably normally will be there. Then that's today's goal. It's we're trying to get different concepts to be described and give some examples. Then later, when you encounter different problems, not sure how to implement your systems, you will be able to ask the proper question with the AI, and then AI definitely will give you a decent one in current stage. So the introduction side is I think that's probably a lot of questions like in your mind already, like what is AI? Everyone talks about AI, but nobody really tell you what is AI. Is someone like standing behind you or standing next to you and just like you, that's just AI? Or is some more like generic concept? Everyone uses it, but I don't think people do have a very really good definition here. We're trying to get a bit like a clear definition in our context here. And then, who is an AI engineer? This is actually a new concept. To be honest, like 3 years ago, this title don't really on the market. I don't really think there is a job title 3 years ago called this. I still don't really think that's a proper job title. It's same as job titles in the history, DevOps engineer, cloud engineer, and what's other things? Like someone invented a title called Dev, Secure Ops Engineer, which is requiring people doing the development, doing the cyber-secure checking, and doing the like operation of the whole system. How could that be possible? Like you're trying to hire one people doing 3 jobs, and then you kind of combine them in one same title. And probably AI engineer require more, so they don't really have that kind of being able to extend the title a bit. So they just invented this title. That's my opinion. But like, what's this AI engineer different from a normal software engineer? Why they don't use the same title? I think that's a question we need to kind of understand. And also, how could you, like, that's actually the goal of us. Like, everyone was have in a project, and everyone have a big, like, a problem statement. You need to achieve something. But you don't really know. I think probably most of the people here don't really know how can we achieve that. That's another question. And for the unit, like people here are taking the data science like a degree. And while you're taking that, probably you see in the future, data science will be the big thing. But like this probably is your final year. Then how could you get yourself being ready for this very, very competitive like market? Before was you only need to compete with human, but nowadays you also need to compete with AI. Then how could you be able to do that? I think that's a question I was trying to like being able to address here. If I haven't, then you can keep asking in the end. So the AI things, that's a very, I think, old diagram about the history. Like we need to know where we are from so we can know or kind of know where we were heading to in the next 2 or 3 years. This is actually a very long time ago, like a diagram about in the history when the AI concept was being proposed. You can see it's actually coming from last century. So it's not just the last 3 years work. It's just the last 3 years you have a big thing happen as ChatGPT moment. And then today it's become a very big thing. So I think when the AI was first officially proposed in 1955, when there is a group of the scientists gathered in the Dartmouth College, and they started to think, imagine about what the future will be. So they're starting to propose the concept of the artificial intelligence and define several criteria of what we want to achieve. At that stage, in the history, people probably will joke like none of this will happen. But if you go back to the history books about what they have defined at that stage, nowadays we actually achieved most of it. So that's kind of, for you guys, is the same thing. Like if you really dream something big, try to dream it and trying to find the path to make this happen. It will be possible. So I think there is a red part there. That's actually a milestone moment. It's called XOR problem. That's kind of there is a divider there. Before is a golden age of the AI. Afterwards is a dark age of AI. I think everyone here shares the same, especially us as a researcher. I think probably share the same worry. It's like there is a lot of AI winters and AI summers comes up and down. But when will the AI things end in this time? We don't really know. There are so many money coming in, everyone trying to be competitive. But my opinion is a bit different. At that stage is because you only have a single neural net, perceptron here, and this is a series. You want to be able to have a single layer of it and get the problem and the model solved by this way. So afterwards, you get that thing, get the AI winter, and then afterwards, you get the multi-layer thing. So actually, the most important things happen in the long before history. That's actually the multi-layers, MLP was actually being proposed a long time ago. It's not just a yesterday things. But after that, until now, you have a lot of engineering problems, and you kind of overcome them one by one until you reach this stage, you get this large language model really working and a bit scary. So, and that's the other part is like in the history what happened. But the milestone moment for this wave here today is from this 2000, I think 2012, and when Hinton was trying to propose this deep neural network concept, and but these things not really come along. It's not really some like a very genius professors come out with some genius algorithm say it will works. We will have some like AI comes. In the past these 10 years, the timeline here is also the taking off time for the cloud computing. So Amazon was trying to sell the product online in 2003. And then in the next 10 years, they figure out they need more computer resources. And until this stage, like AlexNet was being proposed, that's actually 2013, that's like an area when I was kind of still in my bachelor degree. That's the time everyone was talking about cloud computing. And when the cloud computing is there, then you have kind of looks like unlimited computer resources. Then you basically can try everything you want if you have enough money. Then people started to trying and wasting a lot of money, and then you see these kind of big moments in the past 10 years. So nothing actually comes along, and engineer definitely play a very important role here. That's kind of why I don't really like the AI engineering title, but the engineering part is kind of pretty good description about what we will do in this unit and what you will do in the future, because you're trying to have a very big dream, you break them down, and then you're trying to find the feasible plans to get that to happen one by one step solidly. That's what engineers do. So I think that's something we want you guys to do in this unit also. And what's the next? Then is the things about everyone probably interested is as a developer or as a data scientist or something. I'm not sure about some people here. I can see you probably have a part-time job already. In your job, you probably have different titles define you. But what's your title actually means, whether you have a proper title, I'm not sure. But that's basically the most common titles actually today in our job market. The first one is the most common one in when I was graduated. People was looking for the software engineer or full stack developer. At that time, because of the cloud computing is up, so people have so many chances to build applications. For example, the Uber, this kind of online platform things, or you just have a website, you collect the information. All of the applications are actually similar. You just need someone to implement the application on cloud and take the user's input and trying to present something to them. So at that stage, software engineering is very, very popular. And later, the stage is, okay, we seems having more and more data comes. And we started, because of this kind of cloud computing is cheap, so we can dump more data on the cloud. For example, every day, originally for the data warehouse unit, you can see originally we just collect the data we care about, like the transaction data. But nowadays, you probably also want to collect the data about the user's preference, like how many times they click this website, and then how long they stay in another website. Then your data becomes large. How you get the data being sorted out become a bigger problem compared to the software engineer part. Software engineer is just to get the pipeline works and get the data flowing. But later you figure out the data part, just to get the data part hooked together is more complex. Then this is where the title comes up as a data engineer. I think that's the biggest job market nowadays, at least in Perth. Most of the work you see on the Seek or the LinkedIn is actually, no matter how they name it, is actually about data engineer. They want you to get some data in and do some transformation, load it into another database, and then someone will do some business analytics. For example, generate a report. Sometimes data engineer also generate a report, but we don't really train to generate some beautiful report or a pretty format report. But what's a distinguished part of the data analytics is data analytics probably will do some statistical analysis about the data to say, okay, that's actually also some machine learning or AI things here, but it's pretty traditional and older fashion. For example, you probably use a random forest to do something with data analytics things, and so you can report these things to your manager, and the manager can do a good decision. But that's kind of another types of the works on the market. Then is the last one. which is the AR part of like our works today, is called researchers. So all research scientists. In this part, people do starting to collect the data and architecture their model and training the model, monitoring, ships the model to the production, and collect the feedback data again, and then they will check what doing well, what not doing well, and trying to increase the performance of the model again and again. But this kind of jobs actually is quite limited in Paris, to be honest. And if, like, after we kind of finish these sections today, you can understand even you have a lot of like big companies, like tech companies, when it's going to the production, the people actually doing this part work is always be small chunks of it. It won't be large chunks of it. I think I will expand why later, but this is another like diagrams about this kind of the three very popular, because software engineer, nobody actually talking about it. Even through software engineer is kind of every job's required skill sets. You need to know what is Bash. You need to know how to get the application up. You need to know Docker, all of these things. But people stop talking about that. Then these are kind of the three main job titles here. And they have some overlaps. For example, here what we just said is like the data analyst and the data scientist, they probably share some job responsibility. Same as the infrastructure part of the data engineer. So if you're trying to find a job on the market, trying to read through their job descriptions, not really just see the jobs and say their title is not what you want. Sometimes HR won't be able to put the proper name there. Job description is more important, and then you can kind of align yourself with your job description and address your criteria, say I'm fitting into the role because I have done these things in this specific unit. If you're actually doing good with a project in this unit, basically every job titles on the market, you can take it, unless it is some like hardware, software work here, I would say. And I think that's an important diagram. So that's where we're starting to be today. So what's an AI engineering does? We need to first know about what's actually like the product life cycle for AI relevant product. So before this kind of AI coming out, what's our daily works actually is here and here, right side. So for me as a developer, every day my work is you first get the requirement analyzed from the client or some ticket out, and let's say we need to develop this feature. Okay, then we started to build the code. And after we build the code, we need to write the test, or you were doing the test-driven development. And afterwards, your code is ready. You have like a coverage report about all the testing. You have the user test, and everyone was happy with the feature you have developed. Also, you have some governance, you sign off, then you release. And after you release it, you sign off it, you release it, it will go to the production. For example, a cloud platform. Or in older days, it will be some computer, for example, in this room. And then you put the code there and you run your program. They will take the code in, data in, and then show the result out to the user. And for operational like people, core like I think that's called normally IT support or like infrastructure support, like a role before was. You need to keep monitoring, make sure your application is 100% time online, and there is no hackers trying to hack it, stealing your data. And also you need to have some rules here, like trying to collect, okay, user probably like use this feature more, and they probably send the ticket that says this feature is not that good to use. Something like that will be in charge in the general part. So that's the life cycle before the AI was coming, or the machine learning, or the models coming. What do you have? And at that stage is a software engineer stage. But nowadays is what we will shift to the product side is actually model. So like a model will take the input in and trying to deliver the output, like presented to the user. Why this will happen? It's actually, when you think back, it's actually making sense. Because at this stage, what we were doing as a software engineer, or every company's core value, is just building a platform. Which means if you can do it, and other people with enough software engineer, they can also do the same thing. That's what happened in the internet like ages, like when Uber was kind of in America is so popular. China have their competitors. Because everyone can do it. It's just writing the code to taking the data in and build a specific functionalities. There is nothing that special. The things really special is when you go into the market, when you collect, get enough users and kind of maintenance your compatibility with this kind of group of the user. So this will get the whole market harder and harder. And how can we kind of maintain our competence or our high value IP? That's where that AI things comes out. So for example, I actually worked for a company before this ChatGPT area. We're doing the cardiologist scan processing. So if you go to the hospital, if you have some heart issues or something, you go to the hospital, you will take a CT scan. And CT scan will be a lot of, you basically can imagine it like a stack of images. Normally is 512 different sizes, they stack together. And it's kind of like a bit scary, but it's kind of like slice your heart into multiple ones. But when you get that image in, what our algorithm actually doing is it's an image classification task. We just need to classify whether this pixel is your heart vessel or it is not. And then after you have that information, you basically can reconstruct your heart in a 3D spaces. So that's something you need a machine learning and deep learning to help it. That's not something anyone can do, right? You probably can hide your models, hide your data. To get that work, you need to have your data, which is a secret. You also need to have a separate model, and you also need to have a separate weights, because your weights won't be able, the model weights, you won't be able to release to other people. Then because of this, you can protect your own IP. Then these types of the company was kind of shining up. There are a lot of companies actually in these kind of domains. That's why this AI cycle is kind of popping up, which is making sense. And how this happens is like it won't happen, say, I have an idea, and I want to make that happen, so I have that model for you to deploy. It's more happening is you already have a prototype. For example, the model actually works already, then you need to build a product on top of that. That's what's actually AI engineer. So basically the starting point is like the company was building up in 2019. They have some collab notebook thing. They take several slides, the heart, like a CT scans in, and just run the Jupyter notebook and get the result out as a 3D. Actually, can show you guys to get a better idea about what the output is. So this is what's the company name. So you can see this is the software I have built. So this actually is a CT scan coming. This is what's getting out. So what they have at that time is not this whole product. It's just a Jupyter notebook. I think everyone probably uses a Jupyter notebook, right? You just have the Jupyter notebook and you take the data in, you train your data, and in the output, it's not really something shining like this. It will be some images shown out to say, okay, I actually do the work. So that's where being started with. And then you have this kind of, so what do you have? You have a model, and you also have evaluation metrics to say whether I'm good enough or not. Then you're looking into how you integrate it with here, within the whole system. So within the whole system means you need to collect the data from somewhere and then run it. And then you push the data to somewhere to save it. That's basically what's kind of the whole AI system or AI engineer system. And before the large language model comes out, this whole diagram here actually is called machine learning operations. I think it's called MLOps, which is machine learning operations. But nowadays, because everyone calls it AI, because large language model do the artificial intelligence we are looking for, so everyone actually changing this same diagram, changing this name to AI ops, which anyway, we just take it, right? So, but during this progress, you also have other side of the things you need to consider when you're trying to ship it as a product, like what is saying here. For example, this one, like what we have is not really embedded AI, like on the edge devices. It's just on the cloud somewhere. You have a very large computer resources to get that wrong. But you also need to, in the system, you need to check your metrics, monitor it, keep monitoring it. So if one day you have 10 patients come in, but our algorithm only handle the patient from Australia, but some Asia people comes in, the model probably won't be able to handle that. Then you need to know that at least in the system. So you need to monitor it, monitor the metrics. Otherwise, there will be bad things happen, right? So also you need to have the verification and variation. It's also possible like the data coming, like what you guys know probably in the, I think CITS 4009, you have the data verification and validation process. So when the data come in, for example, it's also possible, we have seen that a lot, like the people doing the CT scans in the hospital, they actually, all the clinics, they actually haven't do a good job. So the data you get in is not really that good data. You want to be able to run any analysis on top of it. You need to reject that. So you also need to have that built in. So at this stage, then, when you're trying to build a product, it's not the model anymore. It's more about all the different aspect or the considerations to make this product mature. You need to build each of it in. And also security, and security part is like Australia, I think everywhere in the world is like people very care about this kind of privacy information, especially in the health domain. So all the information coming, they actually be de-identified. So this is another constraint you need to consider about how you design a system. You need to make sure when the user data come in, the whole system, nobody can see that, even I'm a developer. But in the end of the day, when it's presented to the radiologist or cardiologist, they actually can see the name. So this requirement come in is a real world, like a very conflict requirement, but it's a requirement. But there is nothing related to the AI part here. If you kind of trying to say, I just want to do the fancy part, this is more about secure. And this kind of requirements will also pop up for you when you're doing the AI engineer also. So, and then you have kind of some expandability or safety things happen. But like this, basically like when you're trying to do your project, trying to probably use this kind of diagram to imagine like you have a teammates, right? So different teammates want to be able to do the same work in your team. So some people probably will focus on the model side, if you guys have a model to train. Some people will focus on the like a code development side. Or some people, I think that's a less like work here in this unit because we don't really require you guys to deploy some very mature system. So the ops side of the things probably is less, but you need to, like in your team, you need to divide your job responsibility in different side of this kind of diagrams. And then is the question, what is AI? Anyone have their definition about what is AI? Can someone try?
A model.
Okay. Any other answers? No other answers? Everyone agree with what he said? Yeah.
An attempt to emulate intelligence synthetically.
Okay, that's a more official definition. It's more than a model. So I think different people will have different definitions. When people are trying to define it originally, I think still people have a debating nowadays because people are trying to reserve this word with some like really someone standing in front of you, they kind of same as you, but they are not building as you like the blood and flesh. It's human built, but they are same like you. Someone reserve this word for these kind of concepts. But here, in our unit, I will say your answer is more official, but your answer definitely is missing something. It's definitely not just the model. So to get the AI things works, it will first require the data, and then is the algorithm, which is a model you've referred to. But algorithm not really equals to the model. You also, for example, the deep learning models, the architecture is one part of the model, but the training weight is another one. Like even the meta, probably they have the architecture shared with you. You probably don't be able to have the capability to replicate what meta have done and kind of invent the same NAMA because the weight is also part of the module. And this also reference to another part. If you're really trying to get the AI happen, the compute computer resources is also very important. So I would say these three are the most important part of the whole AI concepts. And then when you're trying to do your projects, you will need to think about, for these three different aspects, what you need. Like for example, I think some of the units is about a relational database, like doing the racks on top of the relational database. Then your data probably is more structured data, or it's more like the schema levels of the data. But if you're trying to handle some PDF, your data is unstructured. And then when I was trying to say just now about these CT scans, the data is actually image or 3D image. But some of the data actually video or audio things, that's all different. And different data will require different types of the algorithms. For example, if it's if you're trying to do the CT scan things, as we said, that's kind of machine learning models, that's deep learning models. So it's not really similar as one if you're trying to build in something called a rack with a large language model. So for the model side, it's also different. And if you're trying to use a large language model, it will also different from the one if we just discussed with some projects here. Is like if you have a lot of figures come out, you're trying to classify them as whether that's map or table. That's actually a specific classification model you're trying to build. So it will also different from the models you build for like the large language model things or fine-tuning language model. That's all different. And then it's about the computer resources. If you're just doing something pretty light, for example, for us, actually when we're doing the CT scans, like processing, it's all already pretty heavy lifting. But the problem is it's not that heavy lifting enough like the large language models today. You need to so much computer resource support. At that stage, we still can get the program running finished in 7 minutes and only use the CPU resources. But that's totally not possible today if you're trying to run a Llama 7B model. You will require GPU. You still can run on the CPU, but the speed will be very slow. So because of the data algorithm, it will like a kind of limited what's the computer resources you will need. For example, some of the teams probably need to do something with a large language model. Then you need to consider about between the open source one or just like a core API from the like OpenAI. Then what will be the matrix divide you from these two decisions? Actually, is the computer resources. Like whether you have that like a strict requirement to say I must to use the open source local model. If so, then you can try that. But do you have enough like a computer resources to support you to do that? If not, then you need to find a compromise. So everything here are actually relevant to architecture like an AI system. You need to think about from all these three different aspects. So about the data, there are several different aspects of the data. For example, the modality things. Like in the simple one is kind of classical machine learning area. People are handling the tabular data. For example, you probably have something like the association rule mining in our like data warehousing unit, or for the machine learning unit, you have the house prices, a lot of features there, and you're trying to predict what's the price in the next year. That's what we handled before. But nowadays, it's kind of changing. You're starting to handle in text, image, audio, and even more like research training in these 2 years are trying to handle the multimodality data. And some of the teams definitely will need to handle that, but don't worry too much. If you want to be able to get the like multimodal retrievers, it's fine. But you need to know like what's the problem difficulty you actually handling. And for the whether it's structured data or not, then there are 4 structured data, like the SQL data in the database, because human actually already put the effort in trying to get them organized. That's what happened before was. So everyone was actually, there is a lot of research about the SQL part, but later when we're trying to go into the freedom world, then the data will be more complex, like the graph data we are handling in the group, or the JSON data, or the unstructured context, like text you are handling. That's definitely more difficult to handle. Why the large language model actually become a big thing nowadays is because large language model can handle the unstructured data text in a very good way. And also another thing is about the volume. Like data size always matters. Like even you are handling the structured data, if it's just 100 rows, then you can use Excel to do that, right? You don't really need to bother you write a program and training a model on top of that. But what if it's 1 terabyte? The whole problem will be different. 1 terabyte probably, like 100 rows, you just need 1 people sit there 1 hour and job done. But if it's 1 terabyte of same structured data, you're trying to gain some insight from it, you probably need a dedicated team there and spend probably quite a while to get that data processed with a decent amount of the computer resources. So these kind of things also will distinguish it. And for your projects, don't try to hook the whole data in at the first try, because that's not really worth it. So try with some samples, get the pipeline working first, and then trying to scale up. When you scale up, there will definitely have different problems like emerging. So you probably need to solve a specific problem later, but that's later problem you worry about. Just focus on, at a different stage, focus on different problems. When trying to get the pipeline running, just focusing get the pipeline running with simple data. And then is about the velocity, which is like most of our works actually is handling the data is offload, like the data warehousing work in our unit or machine learning work. You're basically doing you can say you are doing a data analytics role because the data actually being given to you. You can finish the work today. You can also finish work tomorrow. It's fine. But imagine it's kind of real time, like monitoring video data in the in some highly monitored area, and you want to know exactly at a specific time what happened, and the response time requirements is very low, then it will be a very different story. You need to, if it's batch loaded and you're trying to locate how many people's in the image, right? You can just let your computer run probably for 2 minutes and get the result out with probably 99% of the accuracy. It's fine. But if it's a real-time stream comes in and you need to based on that to do the very intermediate decisions. That's actually happened in mining spaces in Western Australia. A lot of trucks there are actually autonomous. So they need to use a camera to detect what happened and send a signal, say stop or going forward, something like that. So if that's kind of the story there comes out, then your constraint will be different. You need to think about, okay, I probably have limited resources, but I definitely want to push my speed. Not really 2 minutes is not acceptable. It will need to be finished in 10 seconds. Then it's a different problem, right? And then the other thing is about whether your data is clean or not, whether you have the noisy things, do you need to label it? And another thing is about sensitive, like what we just said, the public data sets or it's kind of just the private health information you want, and nobody can actually access it. It must be encrypted. That's all come from the real world requirements. And also you need to think about how you version it, and if something goes wrong, how you revert back into the previous versions of the data. So why are we talking about this? And even further, you have this kind of model, like a pushing back of it, is for the software development life cycle. Like here in the AI engineering, it's the same thing. You need to first understand the constraint of your system. So the constraint of the system will come in first from your data, how you get the data, and what the data looks like. When you have this kind of constraints, you actually working out a solution under the constraints. You cannot just do anything you want. So that actually matters when you're trying to analyze your problem. And then is data will also determine which kind of the machine learning model you will use. For example, if it's a tabular data, everyone in the machine learning, they should know that it's either linear regression or the logistic regression things will happen there. For some, the immerse span actually is a very classic example there. There were definitely more things here, but it's kind of like a traditional machine learning or AI actually. And then is a text data. You probably have that in the old days. You have the RNN, and you're trying to do the semantic, analyze whether this one is happy or not, something like that. And you have a chatbot. You fill the gaps. That's actually what we do with the natural language unit before the large language model comes out. We have a template. We're trying to identify what's the intention of this kind of user, and trying to pour out some of the answer entities and fill the template. For example, if one people trying to fly to another city, Then you retrieve the information from the database, and you fill a template, pretend you are a bot, and send the result back to the end user. That's what happened in that time. But nowadays, you probably can just dump the information to the large language model, and they do it for you. The image is a different story. Like what we have done there, like in that CT scan, processing, we actually use the CNN to process it. So if it's an image, it's definitely 2D. So you had to use a CNN rather than RN, right? And audio is adapted from like a CNN, it's 1D CNN, and a video is a different thing. So all this kind of different data format, it's not just, as we said here, it's not just to give you the constraints about what you need to do to design your system. It's also give you the constraints at the AI engineer, give you the constraints how you select your models. And they also have the things, it's like when you have the model side actually will push back like when you're being handled with some data for the system, for example, that's probably not, your manager later probably don't like what I have said next. But think about that. It's like when you get some data and you're trying to solve a problem, and then later you find out the data have a problem. For example, the class imbalance. So you get the data coming and you find out your data seems not really correct. I won't be able to do anything on top of it. Or the data here, they have so many noisy information. For example, the image here, it's very low resolution. You give me the data and you imagine I can be a magic people to get this kind of very bad data and do some magic. That's not really possible. You need to push back. Tell your manager, say, can we buy a better camera? Right. So we can do this work properly. So this, why I'm saying this is I find out that some of the problems, engineers trying to solve it. But in the end of the day, when you're talking with the manager, for example, asking a better camera, if you really propose that solution to them, then, okay, we can buy it the next day. It's not that hard. And it probably just take $1,000 to fix that. But think about the engineer times. If you're trying to solve the problem with a low resolution of the image, then you probably spend a whole week or 2 weeks. You won't be able to have a decent result. Then all the time are wasted. The product won't be able to ship to a perfect status. So when we're talking about the requirements and the constraints from the very beginning, you definitely need to think about it and take it. But the constraints sometimes will also be changed if you communicate well with your stakeholders. That's the important part, like a lesson I have learned in my career. It's like you don't really need to waste your time too much if it's not really reasonable with specific constraints. Like ask the question. That's what I'm trying to say here. So yeah, your manager probably won't like that. And then is the algorithm part of this kind of AI thing. So what we see here is like I trying to distinguish them into these 3 different stages: classic machine learning model, deep learning model, and generative AI model. And the classic ones is what you actually learn in the machine learning units. That's actually, I think we was my data warehouse unit coordinator when I first switched from my bachelor degree, which is nuclear engineering, to the IT. When I learned the data warehouse in 2016, I think that's actually all the algorithm in that unit. And that's pretty hard at that time. The later things, like the generative AI things, CNN things dominating the world, is not really happening at that stage. Everyone was trying to do this kind of SVM and random forest, these kind of things at that stage. But imagine it's only 9 years ago. What really happened afterwards is you have this kind of deep learning things shining up and then become dominating and then become abandoned, and people kind of embrace the generative AI nowadays. That's actually what happened in the past 10 years. It's not really far away. Imagine what happened in the next 10 years. I cannot imagine that.
Yeah, I still remember back in 2012, you have the timeline there. Back in 2012, I have a PhD student talk to me about deep learning. In his paper, he wrote about deep learning. At that time, I wasn't aware of the term deep learning. And I said, how childish it is to use a term called deep learning. by deep? How deep is deep? That's exactly what I asked. So this is back in 2012. At the very beginning of the world is awakening to the term of deep learning. And now everyone knows about deep learning. And just reflecting on my naivety and ignorance back at that time. Yeah, so you never know what term will become popular.
Yeah, and I think everyone is equal in what's in front of us. Everyone is equal. Like in our industry, the only thing not changing is everything changes. Like something not changing at the foundation level, but everything will change on top of it. The front line of it. I think that's the beauty part of as a software engineer. Also, that's the hard part of it. But depends on your personality. I pretty like that anyway. So yeah, so there are several core concepts. Like from this one, we can see classic and mirror. We define it like that, and then deep learning, and then generative AI. Actually, they are not exclusive, right? So this is a diagram from the McKinsey, which AI actually is the biggest concept here, which means, like what you just said, it's a system trying to mimic what a human was doing, make it intelligent. But then narrow it down, you have a machine learning. However, deep learning actually is building on top of the machine learning. You have the MLP, and then you're trying to get it layers, more and more layers, and then you're trying to change the architectures until you go to the transformer, and then you go into the generative AI stage. So everything actually is stacked up together until you go to the generative AI. So the point I was trying to make here is AI engineer is not equals to large language model engineer. So get your concept a bit broad. It's like everything we're trying to do, like ship a machine learning model, will still be a very important thing later in the industry, because I don't really like the research and the cutting edge companies is running so fast. So they leave a lot of people behind it, especially in Western Australia, like the mining company here. They actually been left behind it. So rather than like the big companies in the US trying to apply the generative AIs and use these AI engineers like very fancy concepts, in Perth, probably the Rio Tinto and the BHP companies, as far as I know, they're still struggling and trying to apply some machine learning models in. So that's what happened here. And when you're talking about the AI engineer concept with your probably recruiters from these kind of big companies, if you just say the generative AI, they probably won't be up to that interested. But if you talk about the AI engineer concept and you say, I build a machine learning algorithm and try to integrate it into the system, do something, that will be something they're interested, right? So that's a bit different. And for the classical ones, like I think I don't really need to spend too much time here. I think I already say a lot, but this is kind of the traditional one. You have a classification task. You have the regression task. You probably also have the ranking, clustering. That's all the very, for now, if you see that, that's all very common and simple algorithm you can see. But at the time when I learned it, especially like a DBS scan, that one, when I learned it, so I scaring the lecture notes, spent quite a while trying to get my head around it. But yeah, that's a long time ago already. And then in the deep learning area, what's actually dominating there, I won't say like there is no other important areas, but what's actually dominating there in the first probably 5 or 10 years, computer vision is definitely the part very popular because the CNN will be able to processing the image and do some classification or semantic understanding, or also do some monitoring. That's actually very popular before was, and a lot of application scenarios, especially in China, as everyone knows. And then, but next, in the last 5 years, natural language, because of this generative AI things, natural language started to emerge up, become more dominating. And I think until nowadays, you get this kind of generative AI to merge this kind of two different data together, which is called multimodal data, models. So multimodal basically means you can take the natural language inputs, which as a text. You can also take the videos or audios or the images as an input and generate different types of the output. So I will say in the next 10 years, multimodal like models will definitely will be dominating. There is like no question about this kind of training. And what's about the generative AI model? Like what's the difference is? So this is the latest one. Everyone was talking about this kind of classical models from the deep learning, from the classical models to deep learning, then to the generative AI models. Anyone have a clear concept about what's a generative AI's generative means? No? Do we have any units actually teaching that? Okay, trying to explain.
It learns a distribution and then creates observations from that distribution.
Yeah. So like as this kind of notes was saying there, so basically there are two types of the models. The first one is trying to see the decision boundary. So basically you can see it as a classification model. You get the data in, you say, okay, this is A, this is B. But the generative model is knowing the data distribution. So you will be able to generate a fake data, like the real data, or you want to be able to say that's fake. My interpretation of that is like they are trying to generate something, probably will happen next. It's possible to happen there, or it will happen in another universe. So that's kind of what a generative means. And the first generative model is actually this scan model. They're trying to have a generator and also a discriminator. So they're trying to, like against each other. One is trying to generate the images to trying to trick a discriminator model. So both of them will be able to learn it together to know the distribution of what's a real world image looks like in this way. So that's where it's starting with. Then it's a transformer, and then you get the GPT. So GPT, the G, is actually generative. So that's what it means. And that's what we have today as dominating models. And it's definitely will dominating in the next 10 years because it's so powerful. Like the image generation, the audio generation, video generation. I think OpenAI probably will drop a new model today or tomorrow called GPT-5. Let's see what will happen. But yeah, that's what it is. Next time if someone asks you or in the interview, you can answer your interviewers about what is actually a generative model. So, and then is a compute. Actually, computer also, you can see from the history, like computer also play a very important roles in this AI wave. So from the very beginning, people just using the CPU is already enough with the machine learning models. Until today, but at that time, it's still very expensive for the computer resources. Until today, you can see on the cloud, the H100, 200, the one flops, the cost is very, very low. Like I think it's 1,000 times differences. So you can do a lot of things differently, or you can try a lot of things. Or even you can waste no money there or resources there to try the ideas. So you can kind of understand what will happen in the front. And another part of the computer, why the computer actually benefit everyone, is from the software stack part. So in the very beginning, I think different hardwares will have different a specific software for you to leverage it. But afterwards, when the TensorFlow first pop out, and then PyTorch kind of dominating that later as open source tools, it becomes more easy for us as a researcher to try different algorithms and test it out. Because we can try it fast, so we can verify it fast. And then if it's wrong, we can try another idea. So that's why the whole speed of the AI development is so fast. Like everything is actually tied together. So another interesting story is about NVIDIA. I think NVIDIA now is officially the world's most valuable company. But think about when Alex Late comes out, it's just $4 billion. If you put your $100 in, and today, how rich you will be. And I will say, until now, that's not really an investment advice, but until now, you don't really see any competitors comes out in this industry here for NVIDIA. So everyone says it's a hype, but really, it depends whether you kind of believe in the future or not. But that's kind of an interesting dynamics you can see. And then it's about the AI engineer concept. What is AI engineer? I will try to be quick so we can do some case study. my opinion is AI engineer equals to these three titles as I described before. So research, engineering, and the operation. Research means you need to do the algorithm design, model architecture. You need to do the experiment every day, check the performance, and check the latest work, and trying to say, okay, we probably need another model changes. But engineer is like you need to architect the system, you need to develop the API. Also, you need to think about the security. Like you don't really want to be hacked. And you also need to think about the scalability. Like next day, if you're taking 1 million users, that's normally what happened today already. Like when ChatGPT was launched, like they get 1 million. They are the quickest company to gain 1 million users. No companies, no products in the history being able to do that. And but they definitely have a very good dedicated engineer team there because they've been able to get the whole infrastructure scale up and handle the request. Another bad story, like you can see, lesson you can learn is a DeepSeek. When DeepSeek was trying to dominate, like from the news, everyone was know the DeepSeek. But when you're trying to use the DeepSeek service, even it's blocked here already, but when you're trying to use it, I think there is a 1 month period. They don't really be able to scale up. So which makes sense because they don't really have a very dedicated team there trying to scale the whole system up. And they don't really expect that much traffic coming in. However, that's one important aspect as an engineer, what you need to care about. And then is operational and the monitoring. Different from the older times, we only perform monitoring the latency and whether our system is broken or something like that. Nowadays, as an AI engineer, you also need to monitor your machine learning models' performance, whether that's good or bad. If it's just a generic machine learning model, you probably can accept it's not really performing that well in a short time. But for some critical industries, for example, the medical things we build, it's not really acceptable you're doing any mistakes there. So it's all the things you really need to do. And the tools people actually using in different job titles are also different. But I will say Python is definitely dominating the world. No matter who says any language comes out will replace it. I want to believe that. Because it's already have that much like a baseline, so many users here, it's harder to change this kind of tradings. But the other things different is tools you will need to use. The distinction one for the researcher is you probably use the Jupyter Notebook and Colab a lot because you're trying to see the result immediately. But for the engineer, you probably need to use a Docker or Kubernetes a lot because you wanted to get your whole application to be containerized and be able to scale up very easily. That's why we're talking about the scalability. But for the operations, what you more care about is how you serve the large language model, for example, how you get the data being streaming, and also how you monitor everything. So what we will use basically, the Grafana is a very good tool. It's probably dominating there. Why I specifically mention that is because this is open source tool, and the core developer of this tool actually live in Sorrento, in WA. That's kind of the world first monitoring open source tool. And I met the guy in one of the conference, and surprisingly, the guy is just live near the Hillary Harbor. Surprise. But yeah, for the cloud one, the CloudWatch is AWS cloud tools, but for other ones, they have others. So, and everyone definitely needs to know the Git. So if you're kind of trying to get into this industry, trying to understand, you don't really need to have the practical skill sets now about all the tools we mentioned. Like the Spark, you probably don't really need that until you really be assigned a task in your work. But you need to know the concept because if other people ask you, you need to know what is these things used for. And then you can practice, when you kind of in your projects in this unit, you can start to scan these kind of tables to say what will be the tools I need. And what's the daily routine for different jobs? I think the first one is the question I was leaving previous, research scientist. Everyone was trying to say they're scientist or research scientist, their daily work probably is inventing different model architectures, but actually not. We have a dedicated research team in our company before us. What are they actually doing every day? First of all, need to review, they definitely need to do that. Model architecture design. Since I joined the company, the model architecture haven't changed. So you don't really do a lot of fancy things, say we totally change the architecture of your models, because change that will be quite risky. But for some of the data scientists, they probably want to try different model architectures to see the differences. That's not really a thing if you really want to get that as your work, like daily routine. Ablation study and experiment, that's definitely every day what you need to do. Like every day you probably will get a new data set coming and you need to train it, or you kind of change some parameters and factors. You try it. That's actually the boring part, but that's actually the daily work for the researchers. Paper writing, mathematical formalization, that's two are also not that common. But if you are senior in the team for the researcher team, you definitely need to do that. But if you are just a junior in the team, most of the days you're doing is data exploration, like what you are doing in the data science projects, ablation study, and experiment. That's basically your daily routine. And then other times you will be spending on research meetings, mentoring, or being mentoring, or knowledge sharing, and experiment track, the data pipeline maintenance. Data pipeline maintenance is like when your code was being shifted to the production, it's probably have some bugs. So the bugs is not really means your model has a problem. It's just because your code probably some places haven't handled the edge cases. Then that's not really a big problem, but you need to fix that. So research team will take over that. So that's basically the daily routine as a researcher scientist. And then is daily routine for the engineer team. Most of the days we spend actually is production code implementation and trying to do the code reviewing. Less of the time actually spending on the data schema design, unless you have a new data coming and you need to do the database migration. The performance profiling and validation only happens when you really have a bottleneck of the performance problem. It will come to you and you're trying to do that. And the architecture part of the work normally happens with a team member. It's called a solution architect. If you are junior in the team, you probably won't be able to touch that. However, if you want to get that as your job career direction, you can try to touch on more about that direction, learn from them how they design the system to be more secure and scalable. That's the two very key words there. It's it needs to be secure and it needs to be scalable. Then the third consideration is the cost. The cost needs to be done. That's everyday solution architecture where it works. It's still in the engineering part. And then deployment is nowadays everyone uses CI/CD. So because we're trying to get our code to deploy to the production as soon as possible, so you don't really have too much drama later. And that's another part of the work you will do probably every 2 weeks or every 4 weeks, what you will do every day. For the monitoring part, DevOps, actually this is DevOps, daily works nowadays, but DevOps actually is operational people beforwards. And some of the job title called cloud engineering is actually doing a similar thing here. What's in this job is you probably build a dashboard. That's a one-off work. The dashboard will monitor the whole system performance, like the latency, your CPU utilization, your memory utilization, all these things. And if there's something wrong, you will be able to see it from the chart immediately and know where the problem is. That's the goal of it. And if something's wrong, then the daily work of the operations people is they're trying to view the logs and trying to troubleshooting where the problem actually is and locate the problem. That's what happened there. And I think in our company, our DevOps people, his daily work after he have the spare time, after all these things, is trying to see resource optimization. Another word of that is how could we reduce the cost? Because the company needs to survive if you have the cost being reduced. So normally what we will do is you have a better, a load balancer, you have a better auto-scaling policy, so you don't really spend too much money wasted there, so your kind of results you've been assigned is similar as what you need. So that's what happened with the operational work. Any more questions from this part about the daily works? Are interested questions? No? And we go to the next stage. So next stage is more about the practical side. So this is, I think we have shared a link there about the full stack bootcamp there. There is more practical things in that unit. So you kind of be able to look through like about how to do the front end and the back end development. But in the end of the day, you're basically trying to implement something like this. This is a fully local implementation of this full stack. So when we're trying to say researchers, they need work. In the code, whatever it looks like, is actually here. So normally in the industry, when the researcher is trying to deliver their work, it's a model or weights. And it will have an entry point. You will call it, and then there will be the parameters given to the program. For example, where the data is, or what's the ID of the data. And then the program in this Python package, it will pick that up and then do some pre-processing, all the things you need to do in the Jupyter notebook. And then you kind of run the model, and then the model will kind of output the things it needed to output into somewhere. It can be pushed to the API side, or it can be saved to a file system. And some program errors can pick that up and push to the database. So this part is normally in your team what the researchers was in charge of. And then you will have a dedicated team there trying to have your front end, which is your end user we're using, like what I shared just now. Like in our team, we have a front end team doing the development of this software. So that's what the front end team was trying to building. But the front end team want to be able to invent these kind of things. They need to pull the data from somewhere and send the update to somewhere. So that's the backend was doing. So what we are using is Django and the GraphQL things. Django is just trying to, because I think that's another training if you go to the details of that full stack unit. Front-end work will still be a lot of coding work, but with the AI tools like the cursor, you will spend less time there and quickly build the things. And for the backend, every day's work actually is create, delete, update, and patch, like CURD work. And that's actually can be automatically if you can kind of directly connect to the database. But we haven't because we have some more complex things happen. This is basically this tools comes out from. So you just need to connect that one to the database, and then it will automatically generate the backend GraphQL endpoint for you. So basically, you don't really write any lines of the backend code. You have a fully functional, secured backend. So it will be less time you need to spend there. So you can spend more human resources in the part really added value to the company. That's what's the training happening in the industry. So basically, these two in the system, what we put there is because this one just will give you the capability to do the database, read and write, these kind of things. But you probably have more complex things you need to call. For example, if you guys doing the agent things, for you call the large language model and with a prompt and return to the front end, you don't want to be able to happen here. So that's why we have the Django. And the reason we choose the Django here as a backend is also very simple because this code here as a Python package is normally written in Python. Then if you don't really have a specific reason, say I want to use another language framework, you should get your company have the shared knowledge. So one day, if you are very busy with backend delivery, you can ship the team to the backend to do the work. So that's basically the reason. That's called a technical decision, and why this kind of technical decision was being made basically is based on this kind of judgment. And I think 10 years, not really 10 years, I think when I was 2018, when I would see this, I kind of see it's definitely still dominating by the Django because the Python, I don't really think any other language will replace that. If that's the case, then the backend is either gone, there is no backend, or it will use these kind of mature frameworks. So you don't really need to invent the wheels by yourself. And then the most complex part is into the storage layer. So for us, you will always have a relational database to store your transactional data. So for example, when we're talking about some of the projects you are doing, for example, the geological reports export. When you export it, we'll definitely have some metadata. And if some user log into the system, you need to have the user table or something to maintain that. So no matter what the system will evolves to, it will always need a relational database. Nothing else can replace the relational database. You have to have that. So you will have that. And then for the files, the report things, you need to store it in disk file system. So that's why we have this local disk or the AWS3 to do the file storage. And for the GraphDB is nowadays it's becoming more and more data. That's actually we're trying to use a logic graph to get the unstructured data more structured. That's why you have the GraphDB there. And the VectorDB is another thing. Is like we are doing a lot of RAGs. I think this unit, several projects actually doing the RAG. Last semester, I think last year is a similar things. And one core aspect of the RAG is you need to store it in a vector database, then doing the vector similarity search. And you need a specific database for that purpose. So this is the one we are choosing. But that's not really the only option. You have other options. But this is kind of phony locals, like a full stack I have chosen. I think that will be benefit to you guys. So you can check that and put different concepts, understandings, align with this one. And later, in the industry, when you go to the industry, the diagrams you will see won't be as simple as this one. It will be something like this. So, but don't be scary, because if you kind of understand the different components, what they are doing here, it's actually also simple. You can see here is just the app functions. So it's called app service in the Azure. It's equals to this one. It just means you hosted it somewhere. And I think here, so Azure Storage, Cosmos DB, that's also like equivalent to the things in the previous diagram of the storage. So storage is actually AWS 3. And Cosmos DB is unstructured data. You can use a relational database to store JSON there. That's the same thing. So like why I put this to do the comparison is like trying to get yourself understand what we put there. That's basically all of the like core concepts you need to understand. Later, when you're trying to bring it into the cloud, there will be a lot of fancy names, like the access key wallet. That's just something service for you to being able to do some operations. So it's not really something very fancy. And I think there are the firewalls, and here you have the OpenAI models. That's nothing different from you calling an API to somewhere. It's just a service. So get yourself understand what this kind of diagrams means, and later, if you feel confused with the new architecture or you're trying to adapt new things into the system, mapping the concept around. It definitely will help you to understand it easier. And then is like I try to put 3 case here about what's the AI engineer with a large language model really is, which are the simple ones we're trying to explain. So the first one is RAG. So anyone heard about RAG? Everyone heard about it. Anyone clearly understand what is the RAG? No? Okay. That's a concept probably being emerged up a long time ago. Like from now, it's when the ChatGPT was shining, then it's starting to have this kind of concepts. We have a specific tutorial here is regarding about what is RAG, which R means retrieval, and A means augmented, and G means generation. And this one give a clear explanation about what it is. If you are interested, you can read through it. But for this unit here, I just do a roughly general introduction about what is a RAG. So why we need it? That's the first question. Is large language model, when they're trying to answer your questions, they need to know the knowledge, right? So if you ask them, like, what's the weather today? I don't think large language model can do that. Why you can ask the ChatGPT and they provide the weather today is because they actually access the external service, retrieve some information back, and use that together to generate the answer for you. This is already called RAG. And that's the case. ChatGPT can do it for you, hide all the things in the background. But if you kind of handling the data from your company, for example, you have a large disk of the emails in the past 30 years, and one day your system manager will say, can we try to build some assistant, AI assistant, help me to like retrieve this kind of like in-mirror history logs and provide me with answers. For example, I will ask, in 2022, when Bob sent me an email about that specific product, what he mentioned. This data, like ChatGPT definitely want to have, then you needed to build your own system to make that happen. So how could you make that happen? Then the first step is you need to be able to retrieve that specific data, like a Bob. Okay, Bob is a keyword. And then they're email about a specific product, that's several keywords. Then you need to use that trying to go into the oceans of the emails and get that several emails pop out and digest it to the large language model and generate the results. That's also called RAG. And why it's dominating is because this kind of user scenarios is very common in the enterprise environment. So each companies, they have a lot of data in their database or in mirror, like in mirror server or their document servers. That's what happened. And how can they leverage the large language model with this kind of data? They have no other options. They must build something like this. That's the first attempt that they can do to unlock the possibility of the AI in a small company. So that's basically why AI is so popular, or the RAG is so popular in the last 2 years, because everyone see this is not that hard to implement it. And it have a very clear ways to implement it. So how that happened? So basically your question coming, and if it's in a relational database, that normally happens, most of the companies have their own relational database. I think we have several projects is this past line. So if it's from the relational database, you probably use a text-to-SQL large language model agent, and you give the large language model, say, this is my database structure and schemas, and then you have your query, like Bob, how much products Bob was sold in 2003. Then you probably formalize a SQL called a select amount, then where the seller equals Bob and the year equals 2003. And then you execute that on the relational database, you retrieve the result back, and then you augment the prompt. Augment prompt means basically you have the question there in the prompt, and what you give to the large language model is, this is a question, and then question. And then this is data I retrieved from the database. Use the data I retrieved to answer the question previous, and give that to large language model like ChatGPT. It will generate the response and send it back to the user. So that's basically what the RAG was doing. Another way, the agent is you just cheating, you use large language models. Another way is you probably can build your own models. So I'm not sure whether some of the teams you probably decide in the end you want to train your own model. That's also doable. It's probably more hard. But that's basically is another option you can take. You probably can take text-to-SQL models on the markets, and then because your database structure is more defined, then you can kind of trying to fine-tuning these text-to-SQL models more catered to your purpose. Then you can increase the accuracy a bit. So that's another pipeline. But if your data is unstructured data, then your questions coming, you can use keyword search, like what we happened before, like Elasticsearch or Google search, any search you can do. You search something out with a text, and then you use that to augment the prompt. That's traditionally what you can do. Or nowadays, you still can do that. Another way you can do is you're trying to embed it all over the emails, all over the documents in the embedding spaces. And embedding space, which will be stored in the vectors database. And your question will come in, be embedded by the same embedding model. And then you will run a vector similarity search. So you will retrieve the top 3 or top 10. That depends on your specification. I think there is a better one to illustrate this progress in this diagram. So basically, you can see your text being split at the chunks. Then you use the embedding model, getting it to be a vector. And this vector will be stored in these vector spaces. So this all will be the records of that chunks. When your question comes in, you use the same embedding model, get another vector. And then it's go to the embedding spaces at this. Then your similarity search will retrieve these 3 lots back, because you still have the source of the reference back to which chunks it is. So basically, you can use this question, being able to take out which 3 chunks it is, and use that to create this context, which is the argument prompt, and then send it to the large language model to generate the result. So that's what happened here as a vector search. And normally, when you talk about the RAG, the big picture is this. But when the people in the industry to talking about RAG, what they're talking about is actually a specific this line in most cases. Because before was we want to be able to easily processing this or text semantic search problem, but nowadays we can do that with the embedding model. And another way you can do, but I'm not sure whether this unit on your projects will do that, is another way is fine tuning. So basically you have a large language model and you have your own QA peers. For example, if you are in the industry probably of the geology, you can prepare a lot of QA peers and all the things there. And then you probably grab, for example, the DeepSeek model. You have a lot of QA peers there. You have a small amount of the data here. And you're trying to fine tune it. It sounds like a big job because it's so innovative sounds. But because of this Hugging Face, as I said before, there are so many tools being created in the past 10 years to make the experiment and the trial to be cost less. So there is a lot of tools, like Hugging Face actually have a package for you to just have maybe 10 lines of the code to be able to fine-tune the large language model with your own data. Most of the time, when you're trying to fine-tune a large language model, actually is preparing the data nowadays. So that's one of the options you can consider when you're trying to implement your projects. And I think this is another one called AI agent, which is a very hot topic nowadays. And some of the project descriptions actually mention that. But I'm not sure whether you guys have understand what is an AI agent. Anyone have a description of what is AI agent? Yeah.
My understanding is just like it's like different agents doing specific tasks and work together. They can be sequential, they can be modular, but they work together to nail really complex tasks. So like you're saying, the RAG can be like one agent, like different agent to do different tasks.
Yeah. Exactly. What you described is totally correct. So don't feel like this AI agent title is so fancy or so hard. Like what I'm trying to say today is from the beginning to now is like all of these concepts, it sounds so fancy. But actually the work is done is very simple, at least in this one here. So AI agent, in the end of the day, is just a prompt to the large language model. Or before was, they probably have a lot of other works to be done. For example, they search for it. Or they have code or have a database. They can generate the code and go to the database, execute automatically execute the code and retrieve the information back. That can call probably database agent. It's just an agent is a fancy name for them. But in the end of the day, you're just using a large language model to do the automation task. We are not supposed to be easily implemented before, but it's possible now because the large language model is multitasking. For example, directly generate a text-to-SQL script and running on the database, retrieve the result back. That's normally is not a really stable or possible automation task. I think before 2015, but nowadays it's possible. But possible don't really need equals to feasible or like a solid, because it's all like large language models. Biggest problem is we'll always make mistakes. Then in the system design, you need to cater like how we cater to this kind of like problems. So AI agent, this kind of topic, like the name, don't really feel it's too fancy, like to be scared. But you do need to a bit scared of or worry about it is like the large language model. It's to hallucinate and it do create wrong things, like wrong answers. How you in your system design, how you handle that. That's a problem you need to think about. And another aspect of the AI agent is, like Franco was saying, like it's like if you only have one large language model there, you do the work, it's done. But people say, okay, can I put 2, 3, 7, and trying to get them collaborated? It's like play the games. If you have more and more, the whole things become more and more complex. But that's in the end of the day, that still means your agent still need to do some work and call the large language models, get some feedback, and combine them together and do something for the user. That's it. So don't feel it's too fancy and be scared of that, and don't think it's a very, very new concept. If in the end of the day, it's construct a prompt and call the large language model, get some data out. So when you're trying to coding, you can think about it in this way. And when you write the paper, it's definitely not in this way, okay? If you write it in this way in the paper, it's definitely will be rejected. And the last part is about the observability of your AI engineer operation side, what you should do. So basically what we want is API, microservice, and the machine learning models. We don't really want it like silently to fail. I want to know the spikes, all the things. So that's the goal. And that's like when you're if you're trying to build a startup, that's something you will ignore totally. But if you don't really have this in the upfront, like in the very beginning, the cost you will pay later is very, very high. So when you're trying to design a system by yourself, you still need to think about this problem, because later, if you guys trying to build your own company, you need to think about these kind of problems. And this kind of advice probably will save you, at least from our company, we know it's definitely worth more than $8 million. So what we were monitoring, like in the observability stack, is for the infrastructure architecture level as a developer or engineer, we care about the CPU, GPU, memory, whether it's auto scaling, and whether the worker was being started properly or not. But for the app and user perspective, we more care about the latency or the user journey, whether this user click or use this function specifically or not. You don't really want to spend $1 million and build a feature nobody using it, right? But for this AI specifically, what we really care about is accuracy, your bias, your cost per call, and whether it's fair on top. So this is actually not really a new thing. Even the AI engineer is a new concept. There is a specific book called Machine Learning Engineer, How to Design a Machine Learning System. They specifically discussed what's kind of the metrics you need to monitoring. And also there are services actually just for this purpose. There are something called an ML registry. That's specifically as a service for this kind of usages. So when you guys as a team to build your functionalities, think about all of them. Even you don't really, some of them you think, okay, I don't really need that because my end user client don't really need that. Look, what we are doing here in the project is just an exercise. So we're trying to practice every aspect for you guys. We are not really trying to use the industry level to create their eyes, but you need to have this kind of experience. And later, if it's an interview, when you discuss with your manager or the interviewer, you have something to say, right? That's the most important part. And AI agent stack. So what I given here, the image is a simple one, right? But when you kind of go into the current market status, this is what actually happening in the wild. So you can see for the model serving, which is the large language model serving, there are so many different service providers. Olama probably will be the dominant one if you really want to run a local large language model on your computer. You can try that one. It's probably just install it and several lines of the code. You can get the Llama or DeepSeek small models running. So it can save you a lot of time. The closed-sourced one, OpenAI, Gemini, Grok, they are all pretty good nowadays, and they probably, someone will catching up, someone will be left behind. I'm not sure why they don't really have the Meta here, but Meta's performance definitely is not that good. And then is about the storage, as we presented there about the database. What we choose is these Cauldron things, but you have other options. This is a ChromaDB. ChromaDB and this one, they actually both built from the SQLite. And this is actually a half open source service. This is on the open source part. So if you want a fully local vector storage places, you can choose this side. But if you want don't really want to spend too much time to build the infrastructure or deploy it to a specific machine, because that's where it definitely takes time, you can use the cloud sourced part of it. And then is agent development we just discussing. So you can see you have the name graph, which like a name chain was first built for another name, but later they think this agent will be a fancy thing, so they use that name. And this camel things is one company from China, and AutoGen is Microsoft developer things. Just trying to, if you really want to like use some of these kind of tools, you can try to see their documents and see what the community was saying. But like a personal advice is, because it's still in the warring state, none of them actually win this war yet. So there is possible like one day one of the company actually fell behind. So here, when you're trying to select one of the stacks and the onboarding later in the industry, be careful with that. You probably will be more safe choose a Microsoft one, because if Microsoft actually fail, that's likely impossible. So even if they don't really want to maintain this service, they probably will still have a grace period for it. But if it's other companies as a startups, it probably will disappear the day after. Then you have a very big tech debt, like a tech debt to pay in your company. So it's very risky. So these kind of decisions you need to make upfront. And for the cloud source side is like, you can see you have AWS, OpenAI. I think that two probably is what you will select. If OpenAI fail, then what will happen? I don't know. And for the observability, what we just saying, these are actually the tools, as I said, like used to monitoring different metrics and you define your evaluation metrics, and then you will be able to see what happened there, like good or bad. And towards execution, which is the one I just said, the example in the weather, like forecast. If you ask it about the weather, then it will call some API to do it. That's similar. You probably have other defining tools you want it to call it. And memory management, I don't think in our unit or in our projects we need to use that, to be honest, for now. But later, if you really, because that's also a pretty cutting edge new concept that comes out. And you can see from this kind of image here, one of the common things is each square have a lot of companies here. 5 years later, I can surely say most of them will die. And probably the one survive won't be the one in this diagram. So I think that's the biggest message I want to deliver is now you can choose anyone you want just to get a feeling about what's this tool is trying to do. But when you're trying to, in the industry, make these kind of decisions, think about 5 years later, your product still survive, and they fail. Who will take care of these kind of things, right? And I think that's most of it. Oh, the last one is we are talking about how to build the AI applications in a high level and all the concept things. But another side of it is we can use AI to help us to build it. Right, so I'm not sure, anyone try this tour? How many of you guys, if you tried it, raise your hands. Only 3, 4? How many? None? None others? Okay, that's a homework. Everyone go back, download this one. And claim the free student membership for 1 year and try it. Okay? And
if you use it a lot, it won't last you for a year.
yeah. But you need to first get into the game. Yeah. So yeah, that's definitely will be the homework. So what this one was doing, I think, let me see. We still have a bit of time left. I don't really have other things. So I probably will try to do a demo of